So to begin, let's see if we can get away with any automatic retopology solutions. Our strategy here is not to try to retopologize the whole mesh into one object. Instead, we'll be breaking it down into smaller manageable parts. So for example, the bike seat will be a part, a wheel would be another part. So for now, let's just start with the bike seat. The seat is a fairly simple structure, so I probably wouldn't really bother trying an automatic solution here. It would only actually take about 5 minutes, say, to manually retopologize this, without any explanation anyway. However, in this first example, let's see what auto-generated results we can get anyway. First, we'll need access to the actual mesh, but of course we can't do that with this linked-in version, so we'll need another one. It's easy enough to do. We'll just select our linked copy and go Shift-D to duplicate it. While this will likely take another moment to calculate such a large mesh, we'll eventually have a local duplicate of this object. In the 3D view, I'll press M and move this into the Auto Solutions collection. Then I'll disable the linked-in collection. And now, as we still don't want to be having to work in edit mode with a mesh this heavy, we'll instead head into sculpt mode again. Then I'll switch to the lasso mask tool and then draw around the bike seat. I've got a bit too much of it there though, so I'll go around and using control while clicking, we can subtract from the mask all of the parts that we really don't need to be including on the surrounding pieces that attach to it. Then we just need to go up to the face sets menu again and create a face set from our mask geometry. Then we'll simply go down to the edit face set tool, and as it's already set to delete geometry in the mode, we can just click on the main grey bike section to delete it. Again, this might take a minute, but then we'll be left with just the seat area. It still needs a little cleanup though. By the way, while in the sculpt mode, we have access in the viewport overlays to the sculpt mask and face set visibility options. So for example, we can switch off the face sets if we want. We can also go over to the face sets menu and choose to randomize the colors if we want to change from this purple to something else. In this case, it looks like we've got a lighter gray. Regarding the mask, we don't need to have it all masked anymore either, so we can go up to the mask menu or use the hotkey Alt-M to clear that. And now we can go through and clean this up a little bit more. I'll use the lasso tool to get rid of this separate part on the right, so I'll mask it out and then switch to the edit face set tool and make sure the mode is set to delete geometry. Then we just need to give it a face set and just simply click it to delete it. Notice as this is now only 250,000 polygons, it deletes this way faster. In fact, now it's actually no problem if we want to use edit mode at this point. So I'm going to go Control Tab to switch to object mode, and then I'm just going to tab into edit mode. Everything is currently selected, so I'll go Alt A to deselect everything. And then left clicking and dragging over a section shows that it's practically instantaneous. So we've now got something that we can work with in any of the modeling modes. If we wanted to, we could use Control and right click to use a similar kind of lasso tool. However, I'm going to go Alt A to deselect all that and instead do something a bit more precise, which is to define an edge line around the model that I'm going to use to separate it from the other pieces, which will then be able to just simply delete. To do that, we need to make sure we're in edge select mode, and then I'll select an edge in the creases just at the border where the seat meets the surrounding objects. Then I can use Control when left clicking to select all of the edges that make up the shortest path between those two edges. And then I can just keep going around the model, Control clicking another edge further along, just at the bottom of the crease or just below that, as again, this is the border at which I'm going to delete everything below. So I'll keep going around until we come over to the other side. There's a section where we can get below the seat slightly, so I'll follow it under there and further around. Control clicking further around until it meets back up in the seam, where I'll just keep control clicking until I get all the way around to cover the other sides. We don't need to rush this process. Here I've sped the footage up as there isn't really that much to it aside from trying to keep it consistent and be ready to undo if the shortest path seems to have gone through some geometry you were hoping to keep. In any case, we'll eventually be round to where we started. This is the part we have to be the most careful with, as we need to end with an edge right next to the one we started with. Once we're all the way around, we can press X to delete those vertices. Then we'll see we can hover our cursor over a section and press L to select it. And notice at the top of the seat isn't selected. I'll then press X to delete those faces. The most efficient way to delete everything we don't want though would be just to select the faces we do want to keep first using L, and then Control I to invert that selection to everything else, and then press X to delete those vertices. Then with a little inspection, I'll go around underneath and delete some more faces that probably do underhang a little bit more than I want for the remeshing that we'll do shortly, or rather the decimating and some of the other techniques we can use to eventually fill all this area if we need to. So with that, let's get back into object mode and then come over to the modifiers and start with the decimate modifier. In my view, this is one of the best modifiers that we have within Blender to reduce our poly count. It has some intelligence behind it so that it doesn't just remove polygons uniformly. It can recognize where there are polygons not really contributing that much to the silhouette, and it'll remove those ones first. To see the effects of this a little more obviously, we can turn on our wireframe visibility. We can do that in the overlays menu, but it's such a handy feature, it's worth assigning a shortcut to it. We've got it assigned to the semicolon key. Now with the wireframe visible, I'll click away from it so that it's not a bright orange anymore, and then come over to the decimate settings. Currently we're at 151,000 faces. As we start to slide this down, we can see the poly count getting smaller and smaller. The ratio is helpful too, as a value of 0.5 would be about half of the original poly count, and 0.05 would be just 5% of the original poly count, which is about 7,500 polygons. The modifier also allows us to input a vertex group to preserve areas of the mesh. So for example, while we don't really need to do this in this example, let's just demonstrate it by lasso selecting, by control and right clicking around the parts where we can see the material of the seat folding up slightly. And then we can click the plus icon to add a vertex group, and then click the assign button to add a value of 1 to these currently selected vertices. Then we can select that new vertex group from within the modifier. Then when we come out into object mode, we can see that area has been completely removed while the rest has been preserved. Clicking the arrows to the right of the specified vertex group means that we can invert the influence so that in this case, those folds in the seat material don't lose any vertices at all. Though we don't really need a vertex group in this case, so I'll remove it. I think we've brought the poly count down to a reasonable density of polygons there at this point, so I think we can apply that modifier. The decimate modifier does a really good job, but there may be a few areas where it's not quite perfect. So a useful add-on that comes bundled with Blender is the 3D print add-on. That's going to create a tab along the side of our sidebar here. When we click the check all button, it shows us a few problem areas. Most notably 2 intersect faces and 9 zero faces in this case. We can click on the 2 intersect faces button to select them in the viewport. To make these easier to see, I'll go Alt-Z to switch into an X-ray view mode. And then I'll use the full stop on the numpad to zoom into that selected problematic area. To solve the issue in this case, I think I'll just delete these faces and then just tidy that area up slightly. Then when we click on the check all button again, we'll see that we no longer have any intersect faces. Clicking on the 9 zero faces though, however, we can see that they appear to be pretty much all along the edge. So I'll go through and delete those there. Another press of the check all button and we'll see we no longer have any zero faces. As for the thin faces, most of those are along the edges of the seat too. However, there is this one on the top that I definitely want to fix. So I can just double tap G to slide this out, or in fact, we could probably just press X to dissolve this vertex and then slide this other vertex over to space them out a bit better. Here I've selected the one sharp edge we've apparently got in the model. And for this area, I'll just do a simple delete to get rid of the issues in that area. First, I'm going to try deleting the edges, but I'll undo that with Ctrl-Z and instead delete the faces just underneath these edges on the boundary. Then I can click back on the check all button to see if that's resolved. Then it's just going to be a bit of a rinse and repeat process until we get a healthy enough report from the add-on. Another option for the thin faces, if I press that button again to select them and just track them down for a second, another option is we can go Ctrl-V and then choose smooth vertices, which will relax the positions of the vertices on those selected faces. At that point, clicking on check all again shows that there's no more issues there. The overhanging faces are just those faces pointing down, which would be more of a concern if we wanted to 3D print this object. The non-manifold edges will be all the edges at the border that don't join up to anything, which aren't possible in real life. Hence why if we were 3D printing, we would want to know about any edges like that. To select all those boundary edges, all we need to do is select the whole mesh and then go to Select, Select Loops, and then Select Boundary Loop. It's these edges that here at the bottom that are giving us the most problems. So we can use smooth vertices on all of these so that they're not quite so jaggedly arranged, and then move them down a little by pressing G and then Z. So we move them straight down on the Z axis. This still creates some undesirable geometry with bits overlapping each other that we can go through and treat a little if we like, and generally tidy and delete areas that stand out. Really though, the only things I'm watching for here are very dark normals, meaning that some of the faces are getting stretched too harshly, so I'm finding them and moving them into a better position. Here I'm pressing C to circle select a larger section of vertices, and then using the vertex menu with Ctrl V to find our smooth vertices tool, and then using Shift R to repeat that a bunch of times until it looks a lot better in that area. Then to check if there are any loose vertices that need deleting, hover the cursor over the seat and press L to select everything, and then go Ctrl I to invert that selection. And lo and behold, there does appear to be a single vertex that has escaped our grasp. That is, until now. Sorry, little vertex, but we must delete you. Once again, I'll use the 3D print tool to check our faces, and it looks like I introduced more issues when I pulled the boundary loop down a bit. So I'll select this area here and smooth it out a bit with Ctrl V, smooth vertices and using Shift R to repeat it a few times. Then I'll check all again, and those issues have gone. Then I'll select the 0 faces and then just delete them. Then I'll check all again and take a look at the 2 thin faces, which I'll resolve just by dissolving that central vertex. And I think that'll do it on the cleanup for now. So let's rename this to bike seat _ decimated. Here I've jumped forward slightly and simply copied into the scene another version of the bike seat before we started decimating it, and named it bike seat _ extracted. Then we can duplicate this and rename it to bike seat _ remesh. Then we can try another automatic retopology option so that we can compare the differences. We don't need to see the other meshes though, so I'll exclude those from the viewport in the outliner. Check your filter at the top right of the outliner if you don't have the necessary icon to click on there, by the way. The main difference between decimating and our remesh modifier is that the remesh modifier will make our object one solid airtight mesh. So in other words, the hole that we currently have underneath at the moment will get completely sealed up. So to get started remeshing our seat, I'll add a remesh modifier. I think the most useful of these, in my opinion, for any shape that has mostly smooth curvature and no sharp edges, such as our bike seat here, is the smooth algorithm, as it doesn't care if our input mesh is non-manifold or not. And in any case, it'll spit out a manifold mesh for us while also keeping everything quads. Also, it removes disconnected pieces for us. So this is a pretty useful modifier. Generally speaking, the remesh modifier is a very simple way to reduce the poly count though. Essentially, it's just projecting or slicing a grid through the existing geometry. We have some basic controls to tweak the grid. In this case, the octree depth sets our general resolution, and also the scale setting, which is useful as a kind of alignment and fine-tuning of the resolution. Here at an octree depth of 7, we're getting a decent amount of resolution that we can easily recognize our shape. I'll also enable the smooth shading at the bottom there so that we don't get those hard faceted normals throughout. Also, regarding the normals, I'll jump over to the Object Data Properties tab and check the normals section. And yeah, here I just want simple smooth normals throughout, so I'll uncheck the Auto Smooth option. Back over in the modifier, we can see that we can take the octree depth all the way to the heady heights of 10, which gives us a pretty crisp amount of detail that we had in the original. We are up to about 10 times more polygons that we have in the original mesh now though. But if we did want to simply rebuild this so that we made it all manifold with the underneath all filled in, then this is one way we can go about it. And then there's nothing stopping us from decimating it from here. So let's apply this modifier and then add a decimate modifier. Then I'll set this down to 0.1, which should give us 10 times less polygons. So we're back in the right ballpark. So we're close to what we had in the original mesh now, only a bit cleaner, and as mentioned, we now have a manifold airtight mesh. So in this case, it'll act as a good light blocker or shadow caster within our overall bike. It also gives more predictable results if we want to use this as a Boolean object, for example. At this point though, I'll apply the modifier again so that we can discard a lot of that excessive data and speed up the responsiveness of this, as what we can do now is add another decimate modifier and reduce the resolution of the mesh down to what we had earlier with the first decimated object that we did. I'll set it down to 0.05 so that we're not even at the 10,000 polygons, and then I'm going to apply that. To clean up any little artifacts is going to be pretty easy now. We can, for example, switch to sculpt mode, select the simplify brush, and then enable our dynamic topology. In the settings, you can see the resolution we're working with is set to 10, which gives us actually a lot more polygons than we really need. So using the eyedropper, we can see what resolution this actually is, which apparently is 3.82. So using that setting, I can now brush over any parts that look like they need it to simplify things down even further. Note that we're set to constant detail, so that it doesn't matter how far away we are from the mesh, the resolution should stay consistent to what we have set, 3.82 in other words. Another option to remesh is actually use this dynamic topology option within the menu called flood fill, which, as we can see by looking underneath, gives us a nice even topology all over the model. But I'll undo that with Ctrl Z, as we don't need that extra geometry there in our case. We just want to go over and simplify and unify some parts of the top, wherever we think is a bit messy. Generally though, this is looking pretty good and down to a very reasonable 9,000 faces or so. For reference, I'll rename this to Remesh Decimated. To underscore the usefulness of this remesh modifier, I'll duplicate this object and move it up, and then tab into edit mode so that I can select a bunch of edges that cut across the middle of this piece. And then I'll create a seam in the mesh by pressing V to rip that part of the mesh. Pressing L, we can now see that we have a separated piece. Pressing G to move this off to the side creates a gigantic seam. So let's now add another remesh modifier and see what happens. Leaving the threshold for the removal of a disconnected pieces at 1, it completely removes one of the sides of our mesh. I'll experiment with moving the mesh closer and then tab back into object mode to see clearly that it's now bridging the gap for us there. Though we can see where the seam was, we're now getting a pretty usable result if we didn't want that seam to actually be there after we've remeshed. Moving it even closer shows a pretty smooth transition, but I think I've moved it a bit too far off to the side, so I'll snap it back into place and then just move it to the side only slightly. When we see it with the modifier now, it's as though the seam was never there. This is why the remesh modifier is another really good option for automatically fixing some of our meshes. So with that demonstrated, we can now delete that temporary object and show another way to make a mesh manifold though, if we're giving it a tricky mesh, which to be honest, this one probably is more in the tricky category. In other words, it's not just a few missing faces in the mesh, this is a whole underside missing. So because this is a tricky mesh, with this method, we can get some wild results. So let's take a look at this. So I'm going to tab into edit mode and once again come over to our trusty 3D print add-on, where we'll see we have a make manifold button. Pressing that and we'll see that it has filled in the faces underneath, though it's kind of done this quite simply. We can try triangulating that area with Ctrl T and then perhaps with Alt J then to convert those triangles or what we can there to quads. And we get something kind of reasonable, but still we can see the darkness in the mesh that a lot of those faces are being contorted excessively. The normals are really struggling in some places there. So we can simply delete those there. But depending on the use case, this option might come in handy if it's not quite as severe as we've got with this mesh. Seeing how we're just trying to find ways to close out the bottom of it to make it manifold at the moment, let's throw in another tip, which is to select everything and then convert that selection to the boundary loop and then go Ctrl F and then let's find the grid fill option. Initially this looks like it's gone wild, but opening up the tool options there, we can play with the settings by changing the span value as well as the offset until we get something that could be regarded as passable. All right, let's move on from here though and consider the automatic options available to us explored and wrapped up.